Hi, in this video I'm going to remind you of how to solve quadratic equations by factoring. Specifically, quadratic equations whose leading coefficient, or the coefficient of x squared, is not 1. I've started the first one here for us. The first step you want to make sure you do is take any term that's on the right side and move it to the left side over with the x squared. You want to set your trinomial equal to 0. I did that. I moved the negative 16x over, making it 12x squared plus 16x minus 3 equals 0. Our next step is to take the coefficient of x squared, which is 12, and multiply it by the last term. We're not going to worry about the negative. We're going to multiply 12 by 3, and that gives us 36. I went to the side of my paper, over here, wrote 36, and I listed all the factors of 36, all the pairs. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. When you get really good at this process, you won't necessarily need to write all the pairs. What you need to look for are two factors that multiply to give you 36, that subtract to give you 16. I say subtract because this sign is negative, which means my factors will be different, and that when they're different, they're going to subtract to give me 16. Looking at the pairs of factors, I see that the pair of factors that would work, that multiply to give me 36 and subtract to give me 16, would be 18 and 2. I'm going to take those two and I'm going to rewrite the 16x. When the middle term is positive, that means that the higher factor has to be positive. So this becomes 12x squared plus 18x minus 2x, I brought down the minus 3 already, equals 0. It doesn't really matter if I put the 18x first and the negative 2x last, or if I had switched it up and put the negative 2x, then the positive 18x. From here, my next step will be to factor by grouping. That means I group these two and take out a GCF. Then I will group these two and take out a GCF. The greatest common factor of 12x squared and 18x is 6x. If I take that out and then I divide both of these terms by 6x, that leaves me with 2x plus 3. And that's exactly what I need to get. This binomial is what I need to end up with when I take a GCF out of the second term. So from here, it almost looks like 2x plus 3, but there's a negative in front of both. So I take out a negative 1, divide both terms by negative 1, and that's going to leave me with what I need, positive 2x plus 3. Bring down the equals 0. You'll notice now that we happen to have the same binomial in each term. That's the next term that gets factored out as a GCF. I'm going to take out the 2x plus 3 from both terms. And then if I divided both terms by 2x plus 3, it cancels out, leaving me with 6x on the left and a minus 1 on the right. So notice if I divided this side by 2x plus 3, I'll have 6x. If I divided this side by 2x plus 3, I've got the minus 1. So I bring down the equal 0, t off, rewrite the 2x plus 3. That could equal 0. Or perhaps my 6x minus 1 could equal 0. Solving both equations will leave me with x could equal negative 3 halves, or x could equal 1/6. And there you have it. We're done. Our two solutions could be negative 3 halves or 1/6. In this second example, we'll start from scratch. We need to take the negative 10 and move it over to the other side, which will give us 6x squared plus 19x plus 10 equals 0. If you remember from the previous example, now we multiply the 6 by the 10. That gives us 60. I go to the side of my paper, and I'm going to consider all factors of 60 that add to give me 19. Add because this sign is a positive, which means my signs will be the same. When the sign's the same, I add to get the middle term. And I know that both signs are going to be positive. So think of factors of 60 that add together to give you 19. I'm sure you can come up with several. It's 1, 60. You can go in order if you want. 2, 30. 3, 20. 4, 15. 5, 12, 6, and 10, and then we're back to the 12 and 5. Do you notice any yet that are going to work? We need two numbers that are going to add to give you 19. The pair would be 4 and 15, and they're both going to be positive. So what we're going to do here is rewrite the 19x using the 4 and the 15. So let's rewrite our trinomial. As a 4-term polynomial, we'll have 6x squared. Doesn't matter if I put the 4 first or the 15 first. So I'm going to write the 15 first. Plus 15x plus 4x plus 10 equals 0. Now if you recall, we need to factor by grouping. Group these two and group these two and take out a GCF. The GCF of 6x squared plus 15x is 3x. When we divide both of these terms by 3x, we're left with 2x plus 5. That's what we need to get out of these two. Looking for a GCF, we take out a positive 2. Dividing both of these by positive 2 will leave us with 2x plus 5. And that's perfect because that's exactly what we needed. We needed to have this binomial match with this binomial. Since these two match, that's what's going to come out now as my GCF. I take out the 2x plus 5, and I'm going to divide this side by 2x plus 5, as well as this side. That's going to leave me with 3x plus 2. In the next parentheses, 3x plus 2. Bring down the equals 0. Now we have two binomials multiplied. We're ready to make the t. Set up our two equations. Either 2x plus 5 has to equal 0 or 3x plus 2 has to equal 0. When you solve these equations, you should end up with x could equal negative 5 halves, or it could equal negative 2/3. And those are our two answers. That's how we solve quadratic equations, by factoring using the grouping method. Hope that helps. Good luck with your worksheet.